All right, welcome back. Today, we're jumping right into the absolute fundamentals of programming. We're going to talk about how we actually give instructions to a computer in a way it can understand and, more importantly, remember. We'll break down how to store information and why explaining what you're doing is just as important as the code itself. Let's get to it.
So let's start with a really simple question. How do you tell a computer to remember something? I mean, if you want it to hold on to a number or someone's name or a list of your favorite movies, what's the command for that? How do you create that little memory slot inside your program?
Well, the answer is one of the most important ideas in all of programming. We're talking about storing information so we can find it and use it again later. And for that, it's time to meet the variable, basically your code's very own memory.
So what exactly is a variable? The best way to think about it is like a labeled box or a container. The official definition calls it a symbolic name that stores a value in memory, which sounds a little technical, but all it really means is we give a name to a piece of data so we can easily find it and work with it later.
And this is exactly what it looks like in practice. It's super simple. We take a value, like the number 10, and we use that equals sign to assign it to a container we've decided to call X. Or we can take some text, like the word marvelous, and store it in a box labeled name. That equals sign is the key. It's the action of putting the value into our named box. From now on, whenever our code sees X, it knows we're talking about the number 10.
Okay, so we've got these containers, our variables, but what kind of stuff can we actually put inside them? This brings us to our next big idea, data types. See, it's not just what you store, it's how the computer thinks about and categorizes that information.
Now, Python has a bunch of these data types, but let's just focus on the most common ones you're going to see all the time. We've got numbers, we've got strings, which is just a fancy programmer word for text, and then we've got a few ways to store collections of things, like lists and tuples.
First up, numbers. This is pretty much what you'd expect. Python can handle whole numbers, which it calls integers, or int for short, like setting an age to 20, and it can also handle numbers with decimal points, which are called floating point numbers, or float, like a height of 5.7, and yep, you can use these for all your regular math.
Next, we've got strings. You know, a string is really just a sequence of characters. In other words, it's just text. The most important rule here, the thing you have to remember, is that strings are always wrapped in quotation marks. That's how you tell Python, hey, this is text I want you to store, not a command I want you to run.
Now for lists and tuples. These are both used to store a collection of items in a specific order, but they have one absolutely critical difference. Lists, which use square brackets, are changeable. You can add things, remove things, swap things out. They're flexible. But tuples, which use parentheses, are unchangeable. Once you create one, it's set in stone. Trying to change it will just give you an error. So you might use a list for something that needs to change, like a shopping list. But you'd use a tuple for something that should never change, like a set of map coordinates. It protects the data.
Okay, so we've got all these different data types. But what happens if your data is in the wrong format? You know, like when you have a number that's been saved as text. This brings us to data type conversion, or as it's sometimes called, casting. It's all about switching between these different formats.
I mean, think about it for a second. What should happen if you asked a computer to add the number 10 and the word apples? It doesn't really make any sense, does it? The computer would just get confused and throw an error. This is exactly the kind of problem that type conversion is meant to solve.
Luckily for us, Python gives us a really simple set of tools for this. There are these built-in functions that let you convert data from one type to another. Need to make sure something's a whole number? Use int. Need to turn a number into plain text? Use string. It's a really powerful way to keep your data flexible. And here is a perfect example. Before, we have the number 45, but it's inside quotation marks. To Python, that's just a string of text. You can't do math with it. But after we run it through that int function, it becomes the actual integer 45. And now it's ready for any calculations we want to do. So everything we've talked about so far has been about instructions that make the computer do something. But what about the parts of our code that are meant for humans? This brings us to a really important part of writing good code, things called non-executable statements, basically code that the computer ignores.
Yeah, every program you write is going to be a mix of these two things. You've got your executable statements. Those are the workhorses, the instructions that actually do all the work. But then you have non-executable statements, and their audience is totally different. They're notes and explanations just for the people reading the code. The computer completely skips over them. The most common way you'll see this is with a comment. In Python, any line that starts with a hash symbol or a pound sign is a comment. The computer sees that symbol and just moves on to the next line. It's your way of leaving little notes for yourself or for other programmers, explaining why you did something a certain way.
Now, for longer, more official explanations, Python has something called a docstring. It's a chunk of text wrapped up in 3 quotation marks. You usually put it at the very top of a file or right inside a function. And while the computer ignores this too, it serves as the official documentation for that piece of code, explaining what it does.
So, what do variables and comments have to do with each other? Well, it all boils down to one powerful idea: explaining your work well. Because you see, truly great code isn't just about giving the computer the right commands, it's also about clear communication with people.
And there are so many good reasons for this. Explaining your code makes it way easier for anyone to read and understand what's going on. It actually helps you find your own mistakes because you're forced to think through your logic. It lets other people work with you. And for any big project, it's absolutely essential if you want to be able to maintain it down the road.
This, right here, is really the lesson that separates a beginner from a truly proficient programmer. Just remember this: the best code doesn't just work, it also explains itself. So I'll just leave you with this final thought to chew on. Your code tells the computer what to do. Sure, that's its main job. But who does it explain it to? The answer is you, 6 months from now when you've forgotten everything, or your teammate who needs to build on your work. And that's why explaining well is every bit as important as coding well. Thanks for tuning in.